to business. So we just ran a within subjects analysis that looked at um, happiness, anxiety, anger, and sadness, predicting level of intoxication amongst college students on any given day, right? We found out that the relationship between happiness and intoxication varies a lot across people, right? But the relationship between anger, sadness, and anxiety and intoxication does not vary across people. Now the question is, do these things vary by? We have two things that we could look at here, right? The first one is, do they vary by gender? The second one is, do they vary by sustained attention? Yeah, I am recording. Oh, yep, I'm recording. I'm a minute in. So, yep, we're good. So, if we want to do this, what is our first step? If we want to look at whether or not this varies by gender and or by sustained attention.
What do you mean by sustained attention?
WCST. I guess it's attention shifting. Wisconsin card sort. I'm sorry. It's in there. So the question is, we assess people's level of. I'm going to just keep saying sustained attention, since that's what I started. We assess their level of sustained attention. Oh, that's done saving. And we did that before we started the study. We also assessed their level of biological sex. We did that before the study. So I'm just saying that. I'm joking. I mean, it's 0 or 1. It's coded as 0 or 1. Sustained attention is not coded as 0 or 1. And then we centered one of those. I did not center sex, which is called gender in here, but I didn't center it. But I did center Wisconsin card sort, and I centered that between subjects, right? So each person has one score for sex or gender, one score for Wisconsin card sort, and the question is, do these relationships between mood and intoxication vary by men and women, and vary by each individual's level of sustained attention? How do we test this? Yeah. Okay.
It's sorry. It's just
Yeah.
easier to follow that way.
I mean, let me think. At level 1, level 2, I'm just going to draw one of the moods. We're going to look at mood, predicting intoxication, right? And then we're going to look at level 2, I'm just going to kind of stagger them here, sex and sustained attention. We're going to find the main effects on intoxication, right? And I draw it up here as if it's really predicting level 1, but it's not. It's predicting average intoxication, right? We're also going to look at the extent to which sex, predicts that slope or interacts with that slope. It's an interaction, right? Does that make sense? More sense? Yeah. Okay. So how do we add that to the model here? At the between subjects, yep. What are we going to add? So let's start here, between subjects. Should we just start with gender? He said gender on intox, so it is, technically it's not going to be gender on intox. It's going to be intox on gender. And, yeah, there we go. We need to add gender up here. And now we've added it to our between subject level. We've added it here. And if we hit run right now, what is this going to tell us? Give us one additional piece of information that we didn't have last time, right? Which is what? the effect of gender on intoxication. Let's just do it real quick. Let's hit run. All of this stuff stays roughly the same or exactly the same. Here it is. Gender on intoxication, not quite statistically significant, right? I wouldn't even say that it's sneaking up on it. It's just there. Gender does not predict average level of intoxication, right? But in order to do an interaction, you've got to have that. So let's flip back over here. We're going to add our interactions. We're going to predict our slopes. And the first way that we're going to do this is what? What do we need to add down here to look at the effect of gender on all of these slopes? I wouldn't, I mean, why I don't know about I.
Oh, like gender on hams or ham.
Hams on gender. I like that you call it hams also. Hams on gender. And do we have to do anything else? No, we don't, right? That's it. Gender is going to predict every one of these slopes. And for the slopes that don't have significant variance, it's not technically predicting a slope. It's just looking at the extent to which gender moderates that slope. And what do we see here? It doesn't, ever. Ever, never. Gender doesn't matter. All right, so we can say gender doesn't matter. What do we do next? Actually, before we do that, thinking back to 2 weeks ago, before Thanksgiving, before our brains got mushed with mashed potatoes and stuffing. I make beer bread stuffing, by the way. It's awesome. But beer bread stuffing, but beer bread's so moist that you have to let the bread dry for like a full week. So, yeah. Anyway, before all of that happened, I said there's two ways to do these different types of models. We can technically make all of those interactions and never have to do any of that stuff down there. How would we do? Anybody want to, for bonus points? Anybody want to give it a shot? What would we do? We'll come back to it at the end. Yeah, I'll just run through it really quickly at the end. You can do this one of two ways, and you're going to have to be able to do it for the homework. That's why I'm asking. Let's add in our other between subjects variable, which was what? Sustained attention, or with Wisconsin card sort. So we're going to add that here. We're going to add it here. And then where do we add it down here?
You can do a separate line. Or no, you can just put it after gender.
Yep, you can do that. And you can do that, right? So now we're technically controlling for the effect of gender on all of these slopes, controlling for the effect of gender on average level of intoxication. Theoretically, we could say we're controlling for the effect of Wisconsin card sort on these slopes, or we can say that we're examining the interaction of Wisconsin card sort with those slopes, and we're examining the effect of Wisconsin card sort on intoxication levels, right? Let's hit run. Let's see what happens. We got errors. What does your error statement say?
I got it.
Okay. So looking at this, we see that how will we go about talking about this?
No effect of between subject variables on the slopes. There is no effect.
There's no interaction
Except that, yeah, S.
on S, which is sadness, right? Yeah. So we do see an effect on sadness. We don't see an effect on any of the other variables. I mean, we got that 0.057 up there. It's just annoying, but it's there. So yeah, we can say that it's moderated. Once we've figured that out, what's our next step? Okay, so looking at high and low levels, and that's easy enough to do as well. Let's start with we need to see what our slope of sadness is. So our sadness slope is 0.216, right? Let's flip over and look at high levels of Wisconsin card sort. I've already got them calculated. So let's say high Wisconsin card sort. This is actually high errors on the Wisconsin card sort, which is like worse performance, just FYI. So people who have worse attentional abilities, we're going to call that. We hit save, we hit run. None of these things should have changed, right? We moved that from a high level to a low level, so we still have this p-value of 0.057. We still have this significant effect here of the Wisconsin card sort on the slope of sadness. Our slope of sadness before was what? 0.216. So this is actually very interesting because it shows that for people who do worse on the Wisconsin card sort, sadness doesn't have the same effect, right? People with worse attention, sadness doesn't seem to matter. Or sadness, the relationship between sadness and intoxication is less. For people with higher errors on the Wisconsin card sort, for people with worse attention, when you have worse attention, sadness, the relationship between sadness and intoxication is 0. Now this is interesting, statistics aside, because we tend to think that people with worse cognitive abilities, negative emotion just leads to more problematic outcomes for those people, right? This is an odd instance where this does not occur. Let's go back and let's have a look at people with good sustained attention or good attentional abilities. So we're going to look at low.
And you're making a determination based on the p-value of the intercept of that slope?
No. Yes, I'm sorry. The p-value of the intercept of the slope. Yes. So before it was 0.021, and then when we put that in, it became 0.03, right? And you can kind of guess now where's that slope going to go from here? It's going to jump up by about 18, right? So it's going to be close to 0.4. It should. Let's have a look. These things shouldn't change, or at least not change very much. And we see that it does jump up quite a bit. So this is interesting. That means that for people with good sustained attention, sadness is a stronger predictor of intoxication. And just FYI, sadness, it's not like we're predicting variability in that slope, right? Because there was no random variance in the slope of sadness. It is a true just interaction. These slopes are just different based on levels of Wisconsin card sort. If you're an alcohol researcher, this makes really good sense to you because in alcohol research, we know that there's something called alcohol myopia, right? And the more you're able to focus on something, the stronger an effect something can have. This is especially true with mood and consumption. And so there's actually some really interesting research that shows that people with better attentional abilities are more prone to drink in response to negative mood. So it's cool stuff, and it has to do with the fact that those people probably reap the benefits of negative mood. Now, in truth, those people also don't experience the same level of problems. They're probably able to drink in response to negative mood and not have all of the crap that comes with it. So it's an interesting finding, right? Has nothing to do with statistics other than I think it's really interesting. But it's a nice way to show a cross-level interaction. So this is one way that we can look at a cross-level interaction. Now, what if we want to know if this effect varies by gender. I'm going to set this back to our centered effect, right? What if we want to know if that effect on sadness varies by men or women? Now we're talking about what type of interaction? Three-way cross-level interaction, right? How would we go about figuring out a three-way cross-level interaction?
Well, there are 3 more equations at least we have to write.
Say that again?
3 more equations we have to write here. The one will be gender, slope,
Richie.
Would you have to define like an interaction term and then regress that and then use it?
Perfect. Yes, that's exactly what you have to do. Because anytime you're looking at interactions that are at the same level, you've got to make those interactions using define. Now, we're not going to do that just yet because I want to do something else. We're not going to do that because that's actually what your homework assignment is. Just FYI, Richie just gave it away to you guys. Thanks, Richie. Everybody say thanks, Richie.
Thanks, Richie.
Okay, we are going to do something else though. And we are going to use the define statement to do this. So let's delete all of the things that we had done before. And we're going to do this all at level 1 minus our one random slope for happiness. So remember when I started today, we ran the single regression model that had just a random intercept, no random slopes, right? And we can continue to do stuff, we can continue to do something like that, fixing everything at level 1 and not moving anything down to level 2. And I'm only showing you guys this so that it becomes easier to make these interactions for your homework assignment. Yeah.
Can you say that one more time?
Oh, you weren't here for the first part of this. So earlier, when we first started, we ran a single regression equation where all of the slopes at level, all of the slopes were fixed, and we just had a simple random intercept. Then we redid this, allowing random slopes, and found out that only one of those slopes were truly random, and so we fixed all of the other ones. But we're going to go back and we're going to do it the exact same way we did at the get-go, minus happiness, because we know it has a random slope. So let's just put happiness in here and not mess with it for right now. H intox on CMD happy. All right. And then the other ones were intox on these, right? So we can add those. And we can build all of our cross-level interactions using the define command. So let's start by building, we don't have to build them for H because we already added those. We know how we can do those, right? You can just say H intox on gender and Wisconsin card sort. But if we want to build our cross-level interactions here and put them all at level 1, then we have to do something a little bit trickier. Let's go angst by sex equals anxiety times gender. And I'm just going to copy this. Don't get too excited. Bam, bam. And I'm going to call this sad and this mad. And then I'm just going to plug these in here. So you see what I'm doing is I'm building the cross-level interactions. Will these vary between subjects? Or within subject, I'm sorry. Will these interactions vary within subject? They will, right? Because, yep, absolutely. So that means that these new variables that we're creating are all within subject variables, right? It's taking your gender times whatever your mood is on a given day. So we're going to add this as a within subjects variable. And sad and mad, I'm just going to copy them and just sad, mad. So now we have those within subject variables. And we want to do the same thing for sustained attention. So instead of sex, we're going to call this SA. And we're going to change gender to our Wisconsin card sort. And we're going to add those to our statement up here. SA, SA, SA. Does that all make sense so far? So we've built 6 new variables. Those 6 new variables are our interactions. We've already tested these interactions. We know which ones are going to be statistically significant. Which ones are? The one with, yeah, the Wisconsin card sort with sadness is going to be statistically significant, right? Let's grab all of them. And let's just throw them in right here, actually. I have a little bit of anxiety right now because I didn't do this ahead of time. I was like, oh, we should just do this. And now I'm like, gosh, I hope I'm right. Let's hit save. Let's hit run. We'll find out. Nope, I'm wrong. Within option. Unknown variable within option. No, unknown variable
put them
within
in the
option.
define?
Nope, we didn't. You're right. Thank you.
I mean, I'm defining the use.
In
bar.
use. There we go. Now they're in there. Now we can try this again. Save. Run. Oh, it worked. It ran at least. All of that looks good. This looks like exactly what it's supposed to, right? How come our happiness one isn't there? Well, that's because we didn't fix happiness to be consistent at level 1, right? We said happiness is a slope that varies at the between subject level, and so that slope gets pulled down to the between subjects level with its significant random variance. So if we look at the between subjects level, we'll see our happiness slope, and we'll see that interaction with that p-value that's super annoying. Are we all tracking so far?
So mine says random effect variables declared on the extreme level require numerical annotation.
That's weird. Let me look. Random flex variables declared at the between level.
Still says that.
those and the one above. All of the variables that we created and defined have to be added as within subject variables. And so these results are exactly the same as the results that we had before when we had fixed things, right? And this has gotten us one step closer to doing that three-way interaction. We're not quite there yet. What do we need to do in order to make that three-way interaction?
Well, gender into SI.
All right. So let's do that. We have to define what? What's the first thing that we need to do?
Into SI is equal to gender.
That. You are right. And then we move this up into our use vars. And where does this go? Within or between?
Between.
It's only between, right? It's an interaction between two between subject variables. So we can put it there. We can also come and plug it right here, right? At our between level. Now what do we have to do?
X into S is equal to anxious.
Say that again.
Same three equations.
Yep, same three equations right here. But we're going to have by Sx, by Sx, by Sx times gender we all good there? We're going to create these new variables. I'm going to come up here and just start plugging them in. And where do we add these? Oops, I already added them there. Never mind. They go at the within subject level. Sorry. But you also need to add them in use vars, right? And then we can come down here and we can just throw them right in here. Does that make sense? Who's lost right now?
Three-way.
I'm not gonna lie.
Okay. So we just built these three-way interactions, right? An interaction between each of the mood states, sad, mad, and anxious, and between gender and sustained attention, right? So the gender and sustained attention is completely between subject variables, but the mood is not a between subject variable, it's a within subject variable, right? Anytime you have an interaction with the within subject variable, if you create an interaction at the within subject variable level, it's going to continue to be a within subject variable, even if it interacts with between subject variables, right? Because it has the possibility of varying within person. So those will always have to go in at the within subject. You'll find out if you try and put it at the between subject, because M+ will tell you like you have a between subject variable that varies within subject, and it won't run the model. So we created our three-way interactions between each mood state and the and gender and sustained attention. Down here, we didn't create one with happy because we don't have to, right? Happy is a mood or a slope that's already down there, so we're taking a two-way interaction and predicting the happy slope, which is in essence a three-way interaction. Yeah, Richie.
Where did you put those new variables under between and within?
Up here, you mean?
Yeah.
So I list them under within subject, all three of those. and then also in our use vars list. And each one of these is a within subject variable, right? It's a person's mood on any given day by their level of sustained attention by their gender. So these two things, these last two things are going to be fixed, but this can vary across days for people, right? So then we add them to our level 1 model. Don't have to add them to level 2, they're all within subjects. Does that make sense? We've created three-way interactions, one with each mood state, and we've just added them to our level 1 model, predicting level 1 intoxication, daily intoxication. Now, if we hit run here, yeah, Richie.
I'm still getting the random integration thing, but I looked over everything. It looks like
Should be good. Hold on, let's see. I'll wait for you. There you go. All right.
So if we have a significant effect of one of these three variables, what does that mean? Or one of these, three new variables that we created, what does that mean?
The slope of the interaction variable changes because of another variable.
The slope of mood, right? The slope of mood predicting intoxication varies by both gender and sustained attention, if it's statistically significant. Let's have a look.
Getting some wild error messages.
What kind of error messages are you getting?
It says a latent between level variable is created for an X variable but not referred to on the between level. Please check that is what is intended. That's not what's intended. Specify the variable as a within variable.
Yeah, I don't think that is.
really good point. I just figured. I don't know, actually.
The error message, but I'm giving you an option for
I'm
the
gonna read some
by
of that. See if that first.
sustained attention by sex, but I have it in every
No, I'm paying attention to the next one.
one.
we go.
Sorry, I didn't see that.
No, you're good.
Okay, so none of these things actually vary by gender. In truth, one of them should, but because we have interactions with a bunch of other stuff in there, it doesn't. By theory, we should see this vary by anger, right? We can see our p-value is close, it's 0.099. Let's go back and let's say, okay, we're just going to look at this for angry folks. So we're going to remove the other interactions, and in fact, we do need sad by SA, but we don't need sad by sex, we don't need anxious by sex, and in truth, we don't need anxious by SA either, right? We're going to remove those, this, anxious by SA we don't need, anxious by sex we don't need, sad by sex we don't need, mad by sex we still need, that's part of our interaction, right? And then we need all of those. Similarly, don't need that, don't need that, don't need that, do need that, do need that, don't need that, do need that, don't need that, don't need that. Does that make sense? I think that all makes sense. I mean, technically we could remove this one from, nope, we can't. I mean, we're going to leave that right now because we want this. This still needs to be predicting intoxication for that three-way interaction, right? That's one of our higher order interaction variables, that two-way interaction. We don't technically need it on H, so we could do something like this. And then, actually, we can just delete that altogether because none of those things predicted H anyway. So let's hit save, let's hit run. Made a mistake, of course. Unknown variable in between, SX by SA. I must have screwed something up. Oh yeah, I deleted it out of here. I can't delete that out of here. So save it as our use var again. We run that. And we do actually see that that interaction is there just like it's supposed to be, right? Statistically significant interaction between sustained attention and gender. What's our next step? What's that? Plot it out, right? We can go and set this at high levels and low levels of sustained attention, which are already in here. We're not going to do that because this is your homework for this week. Yep, go ahead, Richie.
Can you show the output again? 'Cause I don't think I got it.
Yep. And it could be like, actually, you know what? Before I do that, I'm going to show you one other way. So this is the hard way of doing all of this, right? And I show you the hard way on purpose. Like there's a method here to my madness. Now we're going to go back, just like when we started today, we did the hard way of looking at the fixed slopes versus random slopes, right? So let's go back. Let's remake our within subject model to just be the slopes predicting intoxication with all of our random slopes. Everybody remember that? That's with hams. So let's go back and put hams back in. We're going to delete out everything except this interaction right here. Delete all of these out. These are unneeded. I'm going to leave that. And so at the within subjects we had, I'm gonna delete all of these as well. We're going to get the exact same thing that we did before, but we're going to do it a little bit different. So HAMS, intoxication on MD, SAD, MD, MAD, MD, anxious, and then we're going to put, I don't want to do this on all of the hams, but let's grab this, A on this, M on this, oops, and S on this. So make yours like this. This is the same basic model that we were working with just a little bit ago, right? Happy, anxious, mad, sad. Now, this is looking at the effect of gender, the effect of sustained attention, and the effect of gender and sustained attention on hams and on the intercept. But we figured out that there's only two interactions here that we need to worry about. What were those two interactions?
Sustained attention on a slope between gender sadness and intoxication.
Okay, so that's one of them. So we need to keep the sadness one, but we only need sustained attention, right? So let's dump gender there. Let's dump that interaction. That's what Richie said. That's the only thing. That was one of the interactions that we wanted. What was the other interaction that we had? There was a three-way interaction that was significant. Which one of those three-way interactions was significant? Mad. Gender by mad by sustained attention, yes. These other ones were not, which means don't need them. We did have one other issue, if you recall. We had HAMS, and there was no significant variance in AM or S, right? So let's S at 0. Let's fix those variances to which one? You mean this one here where it says M at 0? I think it says M at 0. Does it look like an H? I'm sorry.
No.
We can leave this H like this, or you can delete it out. It doesn't matter. But we're going to set M at A at 0, M at 0, S at 0, because we know that those slopes don't have any significant random variance, right? This should give us the exact same thing that we just saw with our last model, but it's dramatically more abbreviated. We don't have to use all of these things that we created, right? The only reason that I created all of these things is to show you that this is going to be equivalent. So let's hit save. Does your model look like this in the bottom? Let's start with that. Everybody make sure that what you've typed looks like this. We have hams, we have intox on gender, Wisconsin card sort, sex by SA. We have M, this is anger, madness, mad, angry, on gender, Wisconsin card sort, sex SA. And then we just have Wisconsin card sort on sadness, right? And then of course we fixed these variances. Up here, the only variable that you have created that we want in our use vars or in our within or between is the between subject interaction sex by sustained attention. Does that make sense? Yeah? Yes, no? Who's lost? Good, nobody. Not sure yet. All right, let's hit save. Let's hit run. Scroll down, looks like it worked. We see our significant three-way interaction on the M slope. So this is anger by sex by sustained attention. Our p-value is 0.024. That's exactly what it was before, right? We also see our mean effects of happiness still really strong. Interestingly, our mean effect of anxiety is now statistically significant now that we've started controlling for gender and sustained attention on the mean levels of intoxication. And we have a significant effect of sustained attention on sadness, our sadness slope, right? Now is where it gets really cool because we can go in. Let's look at this real quick. Now, right now, gender is coded as 0 is 1, or I mean 0 is male, 1 is female, okay? So that means technically the slope of M right here is the slope of anger predicting intoxication at mean levels of sustained attention for men, right? Because men is coded, that's our 0 group. We can come back and we can look at this. We can say, what if we look at high levels of sustained attention errors, technically. We have to change that out, and we're going to have to change out this, which is our interaction variable there. And then, of course, this, and this, and this. And now we're saying at high levels, at poor sustained attention, remember, this is what we had seen before. Poor sustained attention. Sadness no longer is predictive of intoxication. And at poor sustained attention for men, anger is a strong predictor of intoxication, right? So this is weird because now we're saying for men who have poor cognitive abilities, negative mood actually is a strong predictor. That's because men are big dumb animals that are driven by emotion. All right, and then of course we can just swap out gender for reverse coded gender, which we don't have in our data set, so I'm not going to worry about, but I will put it in your data set for your homework because that's what your homework is going to be. Your homework is going to be this exact same data set. It's going to be doing exactly what we just did today, looking at three-way interaction and then plotting out that three-way interaction at high and low levels of sustained attention for men and women, and also a three-way interaction with, or a two-way interaction of sustained attention with sadness, and then writing it up the way that we always do, right? And this will be due next Wednesday. What do we have for questions?
Can you just go back to
The input file? Does this make sense to everyone? You guys look lost. Is it just tired?
Can you go to the define statement?
Yep. Remember, when we do it like this, we're only using this one thing in the define statement. It's the only one that matters. Kelly.
Hi. So you say it's the exact same data set and we're doing the same thing, so we're not gonna have to go through the process of identifying where the variance is significant and all that stuff.
I mean, so technically, you need to put it in your homework, right? It all should look very, very familiar.
All right.
Yes. I would write it up the exact same way that you would in a results section, right? The nice thing is there's now a template and there will be a video up shortly. The data set that's up right now doesn't have the reverse coded gender. Give me a few hours and I will get reverse coded gender in there for you guys so you don't have to make it yourselves. But
So could you like go back to the output file and then explain the three-way interaction?
yeah. So every mean or intercept here, right? So it's showing us means for H and A because we don't actually have anything predicting H and A in our model, right? We only have things predicting M and S. So there's an intercept for H and A. It's just a mean. So this is the mean effect of happiness predicting intoxication. Oops, sorry. The mean effect of happiness predicting intoxication. The mean effect of anxiety predicting intoxication. This is the mean effect of anger predicting intoxication at high levels of sustained attention errors, right? But only for men, because right now it's coded as 0 for men, 1 for women. So it's in our 0 group. In order to get the effect for women, you'd have to reverse code gender, which is why I said I will reverse code gender and throw it in there for you so you guys can just swap those variables out. Does that make sense? As far as the three-way interaction goes, these are the main effects of M and S and H and A. The interaction effects are up here. This is the effect of the interaction between gender and anger. This is the interaction between sustained attention and anger. And this is the interaction between the interaction of sustained attention and anger on, or sustained attention and gender on anger, which is a three-way interaction of anger by gender by sustained attention, right? It's the exact same thing as this defined statement right here. This means the same thing as this. Does that make sense? Yeah?
So going back down to the M.396, you're saying that's the like average effect of anger on
Intoxication.
but only for men because it's controlled by gender.
Yep, only for men because there's a three-way interaction, because there's an interaction with gender, right? So it's not technically controlling for gender, it's because the interaction is men at low sustained attention, high Wisconsin card sort errors. And so in order to get, so that's, you need 4 slopes to understand what's going on here, right? Technically 6 if you want to look at just mean levels for men and women also. But in order to get these 4 varying slopes, you would put in high sustained attention and leave it as gender, and that gives you men at high sustained attention errors, right? Then if you swapped out gender for reverse coded gender, it would give you women at high sustained attention errors. Then if you swapped out for low sustained attention errors and left it as women, you would have women at low sustained attention errors, and then swap out gender again for men at low sustained attention errors. So for that one, you're going to want to have 4 slopes on your graph, right? And that means making probably a new graph. Did I ever give you guys a 3-way interaction graph? Send me an email and I'll put it I'll put it in the homework assignment here for you guys so that you can plug those in. So, you can do that either in one full graph, but I like to break it up by like a male graph and a female graph. That's just who I am. But yeah. All right. Any other questions? There will not be class next Wednesday during finals. Everything else is sent by email or submitted. Richie, do you have a question?
Yeah, so for just going back to the 2 interaction graphs, do we need a different tool to do it? We just have like put in the male and female so this looks tool to do this.
Yeah, I guess technically you could do that. There's nothing wrong with doing that. Well,
What would be the difference? I'm just trying to figure out.
yeah, so the difference is if you only do it that way, you're not actually ever inputting the 3-way interaction, which assuming that Wisconsin card sort is centered, it's not going to matter anyway. It's going to be exactly the same, right? So you can use just the 2-way graph that I gave you guys. Yeah, that's fine. All right. Anyway, it's been fun having you guys this semester. It's been kind of a whirlwind, crazy semester. That's the way it goes sometimes. If you guys have questions, issues, concerns, obviously shoot me an email. And moving forward as well, if you guys are working on something and you run into a data issue, shoot me an email. And 99% of the time, it's a semicolon issue, right? But that is it. It's been great having you guys. This has been a much larger class than I've ever had before, which means that grading takes me a lot longer than it ever has before. But when I started teaching this class, I had 6 people or 5 people, and it made it so much easier. But no, it's actually a lot more fun when there's a lot more people, because I get to ask a question and wait for 20 people to not answer me instead of 5, which makes fantastic. But all right. Other than that, that is it, guys. I appreciate all of your hard work this semester, and I know that it's been a lot of work, and I know that you guys, you typed up tons of results sections, and I hope that you got a lot out of the class. But that is it. Have a good break, and good luck on the rest of your finals.